Hola, ¿cómo están? This is Mr. B, your math analyst. And today we're going to start the series of triangles and trigonometry. So triangles, 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 trigonometry. So if you are having troubles with this, no worries. Do not change the channel. We're going to start with this. So as I said, today we'll start a series of trigonometry and triangles. Okay? And before explaining anything, what I want you to know is to have the big picture. Okay, so at this moment, you should be watching an image of how we distribute triangles. And there are basically two types of triangles. We have the right triangles and we have the non-right triangles. Okay, and when we talk about right triangles, there are just two properties that apply to right triangles. The Pythagoras theorem that most of you should know. If you don't know how Pythagoras theorem works, or if you don't know how to remember the formula of Pythagoras theorem, then I suggest you to click on this link that appears here, and you're gonna see a short explanation about how to remember that formula and some problems that we can solve through Pythagoras theorem. Okay? The other property that applies to the right triangles are the trigonometric ratios. And actually, we're going to start this video with that. Okay? Then we're going to go to the non-right triangles. Okay? And to work when we work with non-right triangles, we need to forget about the Pythagoras theorem and about trigonometric ratios, because those just work for right triangles. Okay, when we talk about non-right triangles, then we need to use the sum of the angles in a triangle. That is a property that applies to all the triangles, right and non-right triangles. And also the law of sines and the law of cosines. But we are not going to see that in this video. We're going to see that in the next videos. So as I said, today we are going to start with the trigonometric ratios. And first of all, we need to answer that question. What are trigonometric ratios? Okay? And we need to start with the word ratio. In math, a ratio is a comparison. So in math, we have two ways to compare quantities or values. One is by subtracting them, okay? And the other one is by dividing them, okay? So a ratio is a comparison of two values through a division, okay? We can represent the ratio in different forms, okay? As you can see here in the slide, we can do it dividing A. Always we read it as A to B, but we can write it as a fraction. A divided by B, or we can use a colon, A colon B, okay? And it's read A to B. And the other one is just written A to B, okay? So that is how we represent a ratio. Now, when we talk about trigonometric ratios, what we are doing is we are taking a right triangle and we are comparing the different sides a right triangle has, okay? But before writing all the trigonometric ratios, we need to see something that is really, really important, and is the angle of reference. So I'm going to explain here, okay? And as you can see here in the drawing, I drew two triangles, okay? And the idea is that I'm going to place the angle of reference in two different places, so you can see how the name of the different sides changes depending on the angle of reference, okay? So let's suppose something. Let's suppose that the angle of reference is this one that we have here, okay? I'm gonna label the sides. I'm gonna label the vertices. This is vertex B, vertex A, vertex B, and vertex C. Okay, so suppose that my angle of reference is the angle A, okay? The side that is closest to this angle of reference is what we call the adjacent side, adjacent adjacent, okay? The adjacent side. And the side that is in front of the angle of reference is what we call the opposite side, okay? There is a side that is the easiest one to find out, okay? And that side is the hypotenuse. The hypotenuse always is in front to the 90 degrees. So we identify the 90 degrees angle by this square that is here. If the square is not drawn, well, we cannot assume that is a 90 degrees. But if you have this L, okay, and the problem says that it's a right triangle, then the side that is in front of the square that we have here, the little square, the 90 degrees angle, is always the hypotenuse, okay? Hypotenuse, okay? Let's keep it like that, hype, okay? So this is how we identify the different sides in a triangle. But notice that the most important thing, or the key factor here, is the location of the angle of reference. Now I'm gonna place the angle of reference in a different place, okay? So again, I'm gonna use now the second triangle, okay? And I'm gonna label the vertices. They are the same. The only thing is that now I'm changing the angle of reference. Instead of being the A, now is going to be. So suppose that now my angle of reference, the angle that is given, the angle that is requested, is angle B. Now the location or the name of the sides is going to change. Okay, so notice that now the side that is near, okay, the nearest side to the angle of reference is this one that is here, and this one is going to be the adjacent side, okay? And now the one that is in front is this one, okay? And this is the opposite side, okay? The only one that's still the same is the hypotenuse. Why? Because the hypotenuse is always in front of the 90 degrees, okay? So this is super important. Why? Because the triangle in different problems could be changed, and the angle of reference as well. So it's very important that you are able to identify which is the adjacent side based on the position of the angle of reference, okay? So that is the first thing about trigonometric ratios. Now, let's call all the trigonometric ratios. So the idea of the trigonometric ratios is the following. Well, the Greeks, when they were communicating, okay, so I'm gonna redraw. I'm gonna take this one as the triangle that I'm going to work with. Okay, so it is here. There you go. Okay, so when the Greeks were working with trigonometric ratios, they knew that they can create different combinations, okay? For example, they said, okay, I can compare the opposite side with the hypotenuse, okay? So they did like this, okay? I'm comparing the opposite side with the hypotenuse, okay? They also said, hey, but also I can compare the adjacent side with the hypotenuse, okay? And the opposite with the adjacent, okay? But also they noticed that it could be reversed. Each one of this, we can reverse them, okay? So notice that I'm just flipping the ones that I already wrote, okay? So, but they noticed that it was very difficult to communicate between each other. So instead of saying, hey, give me the measure of the opposite divided by the hypotenuse, they said, hey, let's give names to these guys, okay, in order to make a shortcut. It's like what we do today. We make abbreviations of words okay, or of phrases. It's exactly the same thing, no? So instead of saying opposite divided by hypotenuse, they said, let's call it sine, okay? So this is sine of the angle. Then the other one is cosine of the angle. This is tangent of the angle. And what about the others? Well, they just try to give a sequence to this. So they call this one, because it was opposite to the tangent, they call it the cotangent. This one is the secant, and this one is the cosecant. Okay? Now, something important that you should know is that in IB, you don't need to memorize all of them. We are going to work just with the first three. So I want you to focus in this. Okay? Something that is really difficult for the students is to memorize these relationships, okay, these ratios. So there is a mnemonic. A mnemonic is kind of abbreviation that help us to memorize. So I'm going to copy the first three that we have here, okay, I'm going to paste it here. So an easy way to memorize this is using a mnemonic, okay? And the mnemonic is going to be this. It's going to work with the first letter of each of the components of the trigonometric ratio. So for example, for the first one, we are going to circle the S, okay, the O and the H, and we are going to call it, let me change the color, I like more this red, the wine red, okay? So we're going to call it so, okay? So means sine is opposite over hypotenuse, okay? The other one, we are going to circle the C, the A, and the H. And now we know that cosine is ka. So ka means cosine of the angle is adjacent over hypotenuse, okay? And now the last one, T, O, A, TOA. So TOA stands for tangent of the angle equals opposite of adjacent. So most of the students, instead of memorizing sine is equal to opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent, the students memorize SOHCAHTOA. So sine opposite over hypotenuse, ka cosine adjacent over hypotenuse, and TOA tangent is opposite over hypotenuse, and it's easier to memorize them in this way. Okay, so now we're gonna see how we use the trigonometric ratios to find the missing side. Okay, so the idea, let's go to this. Okay, this is the first example, and in this example says, okay, we have a triangle. The triangle is the triangle ABC. I'm going to read it. ABC is a right angle triangle in which the angle C is 51, the angle B is 90, and the angle AC is 11. I'm going to draw the triangle first. I suggest you to do it as well. Okay, so here we have the triangle. Okay, so here we have the triangle. Notice that immediately I know that the angle B is the 90 degrees. Therefore, the side that is in front is that's right, the hypotenuse. Okay, so let's identify first the sides. So I know I'm gonna do it in a different color. Okay, so it's very important that you get familiar with the sides. I know that this is the hypotenuse, and I know it because it's in front of the 90 degrees. Okay, I know that this side that is here is the adjacent side. Therefore, this one that is here is the opposite side because it's in front of the reference angle. Notice that the reference angle is 51. That 51 is weird. Let me fix it. Okay, so this is 51 degrees. Okay, so notice something. The side that is given is the hypotenuse. and the side that is requested is the opposite. So I need to think opposite and hypotenuse. So sine is opposite over hypotenuse. Okay, so I'm going to use that trigonometric ratio. Sine of 51 degrees equals opposite over hypotenuse. Okay, and I'm going to change, instead of writing hypotenuse, what I'm going to do is I'm going to write 11. I'm going to replace the hypotenuse by its value. Okay, and now I need to isolate the variable that I'm looking for. I'm looking for the opposite. By the way, I'm going to change the opposite by the letter that we are using here, which is the x. Okay, so every time that I'm isolating a variable, the key to isolate or to solve an equation for a specific variable is to ask always what the number that I want to move is doing. So in this case, the 11 is the number that I want to move. What is the 11 doing with the letter x? Well, it's dividing. So when it passes to the other side, it's going to pass doing the opposite. The opposite of dividing is multiplying. So 11 sine of 51 equals x. Okay. So I'm going to input that in my calculator quickly. Okay. If you don't know where the trigonometric ratios are in your calculator, you're going to able to see them here in this keys that we have here. Okay. Let me focus better. So you can see now better. So these keys that are here, sine, cosine, and tangent. Okay. So let's see what I need to input. I need to input 11 times sine of 51. So 11 times sine of 51. You need to be careful. The calculator should be in degrees. So notice that mine is in degrees. So you need to check if the calculator is not in radians. Okay. So when we press enter, the answer is 8.50, and rounded to three significant figures is 8.55. Okay. So x equals 8.55 centimeters. Okay. And this is the answer for the first problem. Okay, remember that this question is finding the missing side. Okay, let's go to the next one. Okay, in this next one, okay, the question is a similar triangle, but now they are asking me for the hypotenuse. Okay, so please draw this triangle on your notebooks. Okay, I am drawing it. Okay. So notice, if you see my drawing, you're going to notice that the side that is requested is the hypotenuse. Okay? And the one that is given, so this is the reference angle, and notice that the side that is given is the one that is near, okay, to the angle of reference. So that means that is the adjacent side. So they are giving me the adjacent side. They are asking me the hypotenuse. Adjacent and hypotenuse, cosine, okay, ca. So cosine of 44 equals adjacent, which is 6, over hypotenuse, okay? And here we need to be careful, okay? Why? Because the variable is in the denominator. When the variable is in the denominator, I need to make two movements. First, I'm going to pass the x to the top, multiplying the cosine like this, okay? And now, because my goal is to isolate the variable, I'm going to move the cosine to the other side. The cosine is multiplying the x, so it's going to pass doing the opposite, which is dividing. Okay, so 6 divided by cosine of 44. Notice that one of the key skills that you should have sharpened in trigonometric ratios is solving equations. Okay, this is a linear equation, something that you should dominate. Okay, so let's input this in the calculator. 6 divided by cosine of 44, 8.34. Okay, so in this case, the answer of the hypotenuse is 8.34. Something important, if we're checking our answers and we're not sure about that, remember something, the hypotenuse always is the longest side. So if when we find the hypotenuse, we are finding a side that is shorter than than any of the others, then something is wrong in our procedure, okay? Let's go to the last problem. And in this problem, as it is already, it's a tradition in our videos, you are gonna solve it first, okay? So here is a complex shape. So I'm gonna give you a hint. The idea of this is that there are like 3 triangles here. My suggestion is split them in different triangles, okay? So that is the hint. I'm gonna read it. You can see that picture here, okay? It says, JML and KML are right angle triangles with angle JML equals to 90 degrees and angle LKM equals to 90 degrees. If JM, which is a segment, equals 10 centimeters and the angle KJM equals 63, find the length of these sides, KM, JK, ML, and JL. So pause the video and try to solve it. Then come back and we're gonna check the answers. Okay, so I imagine that you already did it. Let's check if you got it correctly. Okay, so here you can see my drawing. Okay, and the advice I gave you before solving this was to, because it is a complex shape, the best that you can do is split it. Okay, so I'm gonna start with the smallest triangle. Okay, the smallest triangle is this one that is here, like this. And notice that it is rotated. So something important, if you don't feel comfortable working with the triangle as it is in this form, you can rotate it, okay, to something that is easier for you. In my case, I'm gonna work as it is, okay? So notice something. The first question here is find the side KM. And when I see this triangle that is here, the side KM is just in front of the angle of reference. That means that is the opposite side. So, and the number 10, which is the given side, is in front of the 90 degrees. That means that it is the hypotenuse. So opposite and hypotenuse sine, okay? So sine of 63 is opposite, which is km, over hypotenuse, which is 10, okay? And now I only need to isolate this, okay? And input this in the calculator. So 10 sine of 63, that is 8.91. Okay, so we already found the first one is in centimeters. Okay, so that is the first one, km. Let's go with the other one, jk. We can still use in the same triangle because it belongs to this triangle. So jk, notice that is the adjacent side. So in this case, we can use trigonometric ratios, or because we already have the 3 sides, we can use the Pythagoras theorem. Okay, I'm going to use the Pythagoras theorem. Why? Because it is important that you feel comfortable working with all the tools. And Pythagoras theorem is a tool that I can apply to right triangles. Okay, so the Pythagoras theorem states that the hypotenuse to the second power, so the square of the hypotenuse, equals the square of the side jk plus the square of the side km. Okay, I have the hypotenuse, which is 10, and I'm looking for jk, and km is given, so 8.91. Okay, so now what I need to do is just isolate the variable. Okay, so I'm gonna pass the 8.91 to the other side. Okay, as you can see here, let me fix the screen so you can see better. There you have it. Okay, so I'm gonna input this in my calculator. Okay, notice something. I have kept in the calculator all the decimals of 8.91. That is important. In IB, there is a golden rule. You don't round intermediate calculations, just the very final answer. So what I'm gonna do is 10 to the second power minus, and I'm gonna, with the cursor, I'm gonna go up. Notice that I'm highlighting the previous answer. I'm gonna press enter. With that, I'm copying and pasting that number, and then square here, then enter. So notice that jk to the second power is 20.61. But I don't want jk to the second power. I want jk. So that means that I need to move that square to the other side. And I'm going to apply the square root, because a power, when passes to the other side, passes as the root. Okay? So jk is going to be the square root of 20.61. And that means that jk, let's input that, is 4.54 rounded to 3 significant figures. And that's the answer, as you can see. Okay, so that is JK. Let's go now with ML. Okay, so in the shape, as you can see, ML belongs to the biggest triangle and is the opposite side to the angle of reference. Okay, so what I'm gonna do is I'm gonna draw that triangle I'm gonna draw it apart. Okay, so let me do that quickly. Okay, here's the drawing. Notice something. I basically drew the biggest triangle, and the side they are asking me is ML. As you can see, ML is the opposite side, okay, to the angle of reference, and I have the adjacent side is given. So adjacent side and opposite side, TOA, tangent. So tangent of 63 equals the opposite, which is LM or ML, okay, as it's the same thing, divided by 10. Okay, so 10 passes multiplying. 10 tangent of 63. Notice that I basically switch the sides in the equation. Why? Because I feel more comfortable working with the expression in the right side. Okay. However, if you want to keep it in the left side, it is okay for you to work with that. Okay. 10 tangent of 63 is 19.6 centimeters. And let's go to the very last one, which is JL. Notice that JL is the hypotenuse. So I can use any trigonometric ratio because I have the adjacent side and I have the opposite side. So I'm going to use cosine. Okay. So cosine of 63 is cosine of 63 is adjacent side, which is 10, over the hypotenuse, which is JL. Okay? Notice that the variable is in the denominator. I need to pass it to the numerator, so I need to make a double movement. First, I need to pass JL to the top, and then the cosine of 63 is going to pass dividing. Okay? So JL equals 10 over cosine of 63. Okay? So 10 divided by cosine of 63 is 22.0 centimeters, and we found all the values. This is the answer for this problem. This video, the main objective, the aim, was to use trigonometric ratios to find the missing side. In the next video, we're going to see how we use the trigonometric ratios, but to find the missing angle. So that's everything for today. I'm Mr. B, the math analyst. Remember, here you can click in the subscribe button to subscribe so we can continue making these videos. Also, if you like the video, please give a like. Okay, if you didn't like it, no worries, but don't do anything. And also, we have some links below where you can find the different practices, okay, that we're gonna have there for you to practice this skills, and also for the slides. So that is everything for today. Keep in tune so you can get the next video, and see you there. Hasta luego.